Hello, Keith.
Hello.
Did you get a chance to see my email?
I was just looking at it a few minutes ago.
Okay.
while we're waiting for people to join, is there anything you want to call out to pay attention to in a read through?
Um, I have shared on the list a couple of preprints. I would like people to give some feedback on that. And I do have a presentation. If there is no other topic I would like to present.
Okay, let's let some other people join. We do not have a set agenda today. One thing I'd like to do is to see if we can remedy that for next time, but then I think we will have time for that. All right, welcome everybody who's here so far. As always, I'll put the link to the notes doc in the chat. Please do add yourself there. We are 4 minutes in. We have a pretty light attendance this week. Let's see. I see people are still hopping on. However, as a first step, I was not able to attend the last session. I don't know if those topics cleanly ended or if there's any follow-ups needed from Jags or Mathau's presentation. Is anybody that any of the other chairs or anybody else here last week confirm that? Or 2 weeks ago?
I was on vacation, so I don't know.
Okay.
Yeah, I was there. I don't recall there being any follow-up.
Okay. We don't have a lot of people on the call here today for this, kind of talking about the gathering ideas for future topics. I know as chairs we've gone through some of this. Maybe we just need to look around ourselves. If anybody has anything that they'd like to add as a desired topic for the future, please do say so either on the list or here.
Yeah, we do. We do. There's the OCP, Open Compute Platform, security project has been developing an OCP entity attestation token profile, and it will be next week at the OCP summit and the adjoining in the adjacent Calyptra 2.0 workshop. There is it'll be discussed. It will definitely be discussed at the OCP summit. I think it'll be discussed at the workshop. I'm not 100% sure. It's nearing a stage of completion. We're trying to get not just broader review on it, but also look into the possibility of how to adopt Verizon as an example to actually use it as a more general attestation solution, so that you don't have this kind of this kind of adaptation that has to happen to verifiers, because maybe for each individual format, whether it be TDX, SNP attestation, right, or CCA. We'd like to
How
get
does
feedback. We'd like to get feedback, and we'll go through the presentation at that time. But we like to get feedback and say, okay, can this be a generic attestation format to allow for more flexibility for future hardware? Yeah, go ahead, Greg.
Yeah, I was probably jumping the gun, but it sounds like AR4SI or like the same goals as AR4SI. So how should I think of it relative to AR4SI and EAR?
This would be something that comes from the attester. It's an EAT profile, but
Oh, it's from, well, I use e-profiles for the verification or the
you can do
attestation.
that
So
too. Yeah, that's
yeah,
actually
but
perfectly valid. But
yeah.
in
Oh,
this
yeah, I
case,
get it
it's
now.
coming.
This is evidence. Got it.
Yeah, it's evidence. Yeah.
Got it. Thanks.
Excellent. So you said that was going to be discussed at the OCP summit.
Yeah, and we like to bring it in. We like to bring it in here.
Excellent. That sounds great. When would we be able to slate that in?
Yeah, so next week will be OCP Summit. The week after, I believe, is TCG. So I don't know if you're planning to hold this meeting. Then I would think the first meeting in November would be a good
Okay.
candidate date.
Okay, for both of these, or for the, or are they intertwined enough they'll just be together?
It's just one thing. It'll be on the OCP EAT profile. I mentioned Verizon as kind of like, oh, why are you presenting it here in this forum? And so I was kind of we're trying to get input from the broader CCC attestation experts, and we're also seeing if it can go into if it could be accommodated readily in CCC open source projects. I'm not just actually I mentioned Verizon, but it's not just Verizon, but also like Coconut SVSM. For
Okay.
instance, I think the impacts to Coconut SVSM though are minimal because this is coming from the attester, not not from the CDM. Okay.
Okay, great. Excellent. Thank you. So we'll have that coming up in 2 meetings from now. As mentioned, we don't have preset topics for this week. I realize this a little late. This is my fault. So we can probably keep it somewhat short this week. However, I do think Usama had an update he wanted to share.
Yes, so should I start?
Yeah, go for it.
Okay, thanks. Let me share screen. Right. So I think I need to get rid of those. Okay, so yeah, so Yonat presented in I think 2 or 3 meetings before some update on tested TLS. And I wanted to today recap a little bit of the complementary part, which was the formal analysis part. And that's a kind of a recall to some of the things and some of the things that we added recently. So the way I would propose is that if you have some kind of a clarification question, please go ahead and ask in between. Otherwise, we keep the detailed discussion till the end, where we can have a better understanding of the whole picture of the things.
And
So
just before you get going, Usama, I know
yeah,
this topic that you're calling the identity crisis in attested TLS protocols has been covered a couple different times here. Could you call out the new aspect of it that you want to update on?
right. So I think I will be covering the new aspects and
Okay.
quickly reminding of the older
Okay,
ones. So I'm
great.
not going to repeat all the things that we have already presented. There were some contention points which I want to clarify a bit more. Like in the last 3 months, also in the IETF, there was a bit of a confusion. And I presented just as a recap, I also presented in the TAC. There was a bit of a confusion there as well. I want to clarify all the things. And somebody said also that this is also, I don't know what was the word used, but that was a very strong word used. So I just want to clarify what that means and what the thing is and try to discuss the different perspectives that we may have with that background. I just want to cover the model and approach, remind you of the vulnerabilities which we have reconfirmed, and propose solutions which you're not already presented. I have just one slide to kind of recap why we need that actually. So this is the system model that I always talk about. What's the bigger picture of seeing all of this thing? This is the cloud service provider, which according to the confidential computing consortium or the general confidential computing model is out of the trusted computing base. And so the thing is that this is the CC platform, confidential computing platform. And think of this whole part as one physical machine. This one is the second physical machine. And let's say they are run by the same cloud service provider. There can be, let's say, similarly other cloud service providers, which are not shown here. And on top of one physical machine, there could be multiple VMs. Let's say I have named them as VM11 to VM1M, M virtual machines running on top of one physical platform. And per machine, there is one coding agent that in the sense of, let's say ARM-CCA would represent the RMM. And similarly for Inter TDX, that would represent the coding enclave plus the provisioning certification enclave. And then the thing is that there is a network stack which the TLS connection, where the TLS connection terminates within the VM, which is taking care of all the keys. Like this key is identifying this specific virtual machine. And that's important because of the consensus protocols. For example, if you have all the valid replicas, all of them are of the same measurements, you still need to identify which specific VM is the one which I am communicating with, because in the consensus protocol, if you do not identify those, it can lead to changing the results of the consensus. That is, you could have multiple replicas which change the result of the consensus, and you reach to a consensus of which was not the proposed value, let's say by the majority of those. So you can change the majority basically. That was one of the confusions which was in the last meetings, that why actually we need this specific key. So that comes from a very strong motivation of such use cases where we need this key. And then the question is why we need this long-term key, um, that is basically justified by which cloud provider I'm talking to, what is the service provider or the cloud provider that I'm communicating with, that basically identifies this specific cloud provider. For instance, if this was one and two different cloud providers, I would know which specific one I'm talking with, because of this long-term key will be bound to the identity of the cloud provider by the certification authority. So that's the whole picture, why we need different keys. And then this is the attesting environment, which has the attestation key, like the coding enclave for Intel SGX or TDX, as I mentioned. And that's the whole thing that I want to talk to within this scope, that this is the setting and this is what I want to talk about. So what are the goals? Jonat presented the goals already. I want to talk more from the security perspective, let's say from formal perspective, how these high-level goals could be translated to what I can actually verify. And we want to preserve the standard TLS properties. Of course, we don't want them to be unsatisfied, which means that the server authentication and the secrecy of the session keys should be maintained. In particular, along with other TLS properties. Remote attestation, integrity of evidence, freshness of evidence has been a bit contentious. I want to clarify the motivation for freshness, which is that it's providing two main things. One, namely the binding to a specific remote attestation interaction that is to identify different interactions at different points in time so that it cannot be reused in a different interaction. And the recentness, which means that the evidence was recently generated. It's different from binding, which binding is just associating it with a specific interaction. And recentness is that it was recently generated. So the two things, by nonce, it can provide both of the things which lead to the intra handshake. And then there is a third property, which is the refresh of evidence, which means that at any point in time, even after the establishment of or typically after the establishment of the connection, I can get the runtime state, which is the latest one as compared to the one with which I established the connection. Composition goals that I have two different things, which is remote attestation and TLS. How do I combine or bind them together is this property binding of remote attestation and TLS, which is saying that I can bind evidence to a specific TLS connection and it can be interpreted, let's say TLS connection is in itself can be identified in different ways. And here I have written three technical ways of identifying what specifically one could mean by TLS connection. One is the shared secret GXY, which means that the client and the server has established a shared secret after Diffie-Hellman exchange, which is strictly less powerful than having a handshake traffic secret of the client, which means that the secret with which the handshake messages are encrypted. I have a picture next to this slide where I will show. And then the third step is the application traffic secret of the client, which means that the one with which it will encrypt the actual application traffic. And then for relay attacks, we also want that the evidence is generated by the same server that is authenticated, meaning that I'm assuming here server as the attester, and I want to ensure that the server which generates the evidence is also the one which is authenticated by the TLS. Evidence from the remote attestation side, authentication from the TLS side, and we want them to be bound together such that that's not a relay attack is not possible.
Yeah, hey, Osama,
Yeah,
just kind of
yeah,
a interpretation
sure,
issue. When you
sure.
say standard TLS properties include secrecy of the session keys, my
Mhm.
interpretation of the TLS specs is that that there is no such interpretation. I mean, there is no such requirement at the endpoints, and that's why. And you see that all the time with TLS stack implementations, right? They're implemented in unprotected environments, so therefore the session keys are vulnerable from that perspective.
Um,
So I think
do you
I think it would be that the session keys are not exposed in the communications link, but I don't think absolute secrecy is a requirement for TLS, right?
do you see the screen, the browser, or do you still see the slides?
I see the browser, but I'm saying
Okay,
that
so that's
I'm saying yeah, I'm saying that that's yeah, I know that IETF guys claim that, but I mean the fact of
yeah.
the matter is we know there's a huge difference between TLS anchored in a trusted execution environment and TLS in user space. And usually but usually most communication sessions make use of TLS in the user space, which means that the session keys are in user space, right?
So I
That
think
yeah, that's
I
the
think
whole reason
there's a distinction here.
yeah, go ahead.
There's a distinction here on who it's secret from, and
Yeah,
I'm not
yeah,
sure
exactly,
I've heard
exactly.
a distinct difference. Like, so if you guys are calling out a difference there, but like it does need to be secret from in scope attackers, like on the network, if that's who you're protecting against.
Yeah, yeah, that's yeah. So when we're what the TLS spec says and what Sama, you're pursuing a threat model against TLS. So I think
Mm-hmm.
And so I'm kind of getting at, okay, what is your assumption? Are you assuming that just because somebody's implemented the TLS standard according to what's written, that the session keys are actually protected? Because if that's the case, we don't even need to attest to them at all.
So let me try to kind of understand what you are saying. So are you mentioning the case when the network that the connection is terminating within the VM, the confidential VM? Is it the case?
I
Or is
thought
it
you're
the case that you are terminating the connection somewhere else?
okay.
So
The confidential VM may still have may still have multiple entities running inside the VM context with code coming from different parties. The
right,
TLS
but
session
the
keys may not be protected from that perspective. So if one sub VM is trying to make a TLS connection, its session keys may not be protected from another sub VM.
So within the VM, of course, the keys will be available to all the components. That's what I believe.
Yeah,
So just to be clear, so we are talking about the session keys, right? And you
yeah,
are saying that within the VM, sub VMs, let's say, or sub components within the VM or processes within the VM would all have access to the application traffic secrets
yeah, yeah,
and all the session keys, right?
yeah, yeah. In
I,
fact,
I, I, I absolutely agree with you. So this is
yeah.
the protection boundary, like which is you cannot go within that. So this network stack was to show just that the connection is terminating within the VM versus terminating outside of this in some other
Okay,
component.
okay, okay. So your threat model is just to be clear, your threat model
Mhm.
only cares about session key protection such that it's between VMs, not within the VM.
Sure.
And then
Yes.
okay, we're talking about the same thing then. Okay, yeah,
Okay.
continue, please.
Sure. And I don't believe by any means that would be possible within the VM because that's your protection boundary, unless you use something else like SGX. So there, that would be then the process will be your boundary. And then you protect your session keys and all the application traffic secrets, all the handshake traffic secrets, and so on from that specific boundary.
Yeah, no, I was thinking something along the lines of if you if the platform provider implemented something like global platform sockets API. So there, the TLS session keys are all are all protected within the context of a platform TEE. So it would so the network stack would not be self-contained within the VM from that perspective. Rather there would be a delegated trust to what something on the order of what you're calling a secure element. It would be like a TEE that that has high security privileges on the platform.
Okay, that would be very interesting. I haven't explored that if you can send on in the chat
Yeah,
or
I'll send that
somewhere in
over to
the
you.
that
Yeah.
would be perfect. Good. Then if there are any other questions, I can quickly take now, unless otherwise I proceed with the security goals. Approach. So we have very quickly talked about it many times. This is the formalization part, which is consisted of two main things, namely formalization of the security goals that I have just shown here into something in a logical formula form, and formalization of the protocol which tries to achieve that. For instance, let's say the internet draft which was proposed and so on, to some formalism which is in my case applied by calculus, and to check whether there is an attack or otherwise to prove that there is no attack. With that, the high level bit of this approach is as also presented before, just a quick recap that there is an adversary in between the client and the server. Server is the attester from remote attestation perspective. And from remote attestation perspective, client is acting as a verifying relying party, combining the verifier and the relying party roles. And then what we want to achieve via all of this is, or let's say the approach basically not to achieve. So the approach here is that there is an adversary in between which can take the messages, and then this prime is basically showing that it can modify those messages or create the messages of its own, and similarly applies to all of the protocol, which we are verifying in this case, not the standard one, the standard TLS, rather the attested TLS. With this background, or maybe I can pause for a second to see if there are any clarifications on this point or this
On
part of,
on that last diagram, are you just describing
yeah.
a normal TLS man in the middle situation here, or is there something unique to this that you want to call out here?
I wouldn't call it specifically man in the middle. It's more of an approach that basically is taken. That means any message that a client sends or any message that a server sends is not passed directly over to the other endpoint. Rather, it passes through and can be modified. And this can generate a new message in between and collect informations from all the sessions, combine them together, put on new things, and then put it in some other session and so on. So more of the approach perspective rather than man in the middle. I'm not talking about specifically attacks. Attacks I will talk about in this section.
Okay.
Good, then about this part, replay attack is the first attack, interoperable RTLS, one of the adopted projects of the SIG. Basically, the trace is shown in the top that I want to relate to what a practical attack is at the bottom, which means that server finishes one session and the client finishes, or in the trace, basically, I see client finish occurring 2 times. In this, for instance, client finished is here and server finished is here, which means that an honest server has executed the session only once, and the client has been tricked to accept the connection 2 times. That's basically the attack. And more specifically, what would happen is that client, of course, in TLS initiates the connection, sends over client hello, the adversary forwards it. That's the same adversary which I had in the previous figure. It sends over server hello up to server finished, all the messages. It takes that, forwards it to the client. Clients accept connection, and this is the client finished happening here. So time going to the right in the traces is basically time going to downwards in the protocol. One-to-one mapping, this event which is seen in the trace maps to this specific event, and then the client accepts the connection, sends over the secret data. And let's say after some time, it wants to do session resumption. By it, I mean the client. What will happen is it will go through session resumption process and establishes a new connection. What it will do is it will send over client hello again, and through all of this, the adversary can select not to forward that to the server, the honest server, and then it can replay the old evidence that it has obtained in the certificate message from the actual server. And then it will be the adversary that the client will connect to rather than the actual server. So that's one possibility. That is the replay that evidence, if not bound to the specific TLS session. And in case of interoperable, basically there is no binding at all. There is no nonce at all. So absolutely replayable. And this is one specific instance of how this could happen in 2 different sessions via session resumption. Second attack, we have talked about it a few times. I just want to quickly recap. Cloud.example.com is what the client wants to talk to. Server acts as the attester, and basically it can be rerouted over to cloud.random.com, let's say, because of no identity check at all. And that's what we called as the identity crisis. And it's no longer a theoretical attack, as I have been presenting since February this year. It's already been practically demonstrated that this identity can lead to practical attacks. Wiretap fail and battering or something like that is what they called it. Just released last week, and you can have a look. So that basically certifies that identity is important. If you don't check identity, you can basically terminate connection anywhere in the world. And that includes basically, let's say, the hacker's own laptop because there is no identity check. And if the main point that's typically raised is, hey, but that's the physical attacks are out of scope. Then the question is what we are protecting against. That's my whole point. And I'm absolutely fine with someone saying that this is not an attack. Fair enough, but I need that. What are you protecting against then? If it's if it's the cloud provider has a physical access, and if you say that the trusted execution environments cannot protect against those, then what are you protecting against? That's a pure mismatch in the threat model itself. The third one, which is new, is something like this, which is related to the binding. And this is based on the recent research that we have done. So I mentioned in an earlier slide 3 different ways of binding the evidence to the session or to the connection, let's say, to be more precise. That was GXY, the handshake traffic secret, and the application traffic secrets. And in this specific case, I'm showing that if there is a weak binding, what could happen, for instance, in the absence, let's say in the absence of binding, absolutely, then there is that the attestation request that is sent over can be forwarded to a genuine TE, get an evidence and relay it over to the verifying relying party, and then the attested channel will be established between the verifying relying party and the malicious attester rather than the genuine one. And now comes the point that if there is some binding, how strong that binding is. And that's basically, sorry, I'm skipping back to go to this slide. Basically, these are the um, three levels of binding, which how strongly the evidence is bound to a specific session. And to give you intuitively an idea about this, I couldn't make a figure, but the idea is that this GXY is computed at this point in time, where the client has sent its GX, the server has its GY, and it can now compute GXY. So this is at this point in time, meaning that evidence is bound only to this part of the session. The next one was handshake traffic secret, with which all the messages will be encrypted, and that is strictly stronger than this, which means that it includes this part, but it also includes the server hello message and is computed at this point in time. And then the final one is the application traffic secret, which is generated at this point in time, which means that it has transitively all the other parts basically included inside this, because this running hash is computed over all the previous messages and computed together. So which intuitively shows that the 3 levels of connection, GXY, HTSC, ATSC, are basically showing 3 levels of binding which one can have. And for intra-handshake attestation specifically, I want to intuitively reason about this. I couldn't get it done formally yet, but the idea here is that, I mean, I can show that the property does not hold, but I'm still looking for some reasoning about how to argue about it. The idea here is that in intra-handshake attestation, you need evidence to be sent over in the certificate message. And the third level of um, the highest level of connection that I just mentioned, the application traffic secret, basically needs to connect or bind up to this level of the session. And intuitively, that's not possible because you're sending over evidence that the maximum that can be bound to is up to this level. For instance, what I could do is in intra handshake, I can introduce new messages, which could be something like I have certificate and certificate verify unchanged. I introduce new attestation message, which carries attestation, then and submit it at this point in time, which would mean that I could have now the contribution or the binding to both of these messages in addition to these 2 messages. But that doesn't buy me much because this message still is not covered. And if I do, let's say the other way around, I do it after finished, if I want to cover messages up to finished, like really like this point in time where I have the application traffic secrets. I introduce an TLX extension where I introduce attestation message here. Then it breaks the property which finished is supposed to provide, which is the agreement over all the previous messages, which means that this attestation message that I now introduce will no longer be covered via uh, this handshake log, which is sent over already in this message. So there is an inherent contradiction by doing it with intra handshake, and that's where post handshake is the most reasonable form, where the exporters which are already defined at this point in time bind to all of the session and all of the messages up to this point in time. And using RFC 92611, one can basically use these exporters as part of the, let's say, the nonce for the evidence generation, and then it trivially binds up to all the binding that or to up to the full handshake that we need basically.
Hey,
So
can we go back a little
sure,
on that point?
sure, please.
Why can't both be done? Sort of the intra handshake attestation and the post handshake attestation, where the post handshake attestation definitely binds, because the intra handshake attestation does have some security value, even though it doesn't have a full establishment of the binding between the session and the
Mhm.
attestation. I, I, unless I misinterpreted you, you seem to indicate that it can only be one or the other. I'm asking if both are not possible.
Sure, that's absolutely possible, or theoretically nothing is impossible, and that's exactly what was raised in defense of the intra handshake proposal in one of the RATS meeting. I
I see.
remember the editors said that, hey, that's what we can do is basically we can have a combination of intra handshake and post handshake. And when we actually explored that, how would that would actually work, it turned out to be very complicated. Like I I don't see any specific value of using it in combination rather than just post handshake. So my kind of question to you in return would be, what value do you see in using the combination? I mean, you are by doing intra, you are introducing more complexity, which could simply be avoided by using this. This is our goal, right? We want the binding to be that this is the server I'm talking to, and the one which is attested, and the one which is authenticated.
Yeah, and I
What?
think maybe not in the maybe not in the context of the RATS discussion, but I think I've raised it before in the context of the side meeting at IETF about a year
Mhm.
ago. There a- any situation where where TLS performance metrics are critical, then starting the application session, I kind of opportunistically or at risk, however you want to say it, with you know. Um, it could be used as an alternative where the where where the application session can start, but it could be immediately terminated when the if the application related attestation is not verified. So it doesn't necessarily make for the greatest user experience, but but I think the working assumption would be that the application attestation will be verified and the connection can
uh,
continue. Uh,
just to clarify that point before you go to the working assumption. So your point basically is, what you are trying to say is, in my understanding, you are saying that, let's say I have post handshake attestation.
yeah.
Let's say using RFC 9261, what you are saying is that I established a connection,
Uh,
and then the attestation did not pass, and I have to now abort the connection. Is
yeah, you
this
can do that. Yeah.
that
So,
the
so
use case that you were mentioning?
yeah, so I mean, anybody on this call who's had to ship chips before with the networking connection knows that, particularly in the consumer device space, knows that OEMs benchmark the TLS stack performance, and they do it against well-known applications like a well-known streaming service. Um,
Mhm.
if you inject attestation in the application flow, you'll have to justify not to the consumer electronics providers and the commercial streaming application providers why it is worth a potential disruption to service. So I'm saying why if you can make it if you can make the addition of the attestation as unobtrusive as possible, then then the impact to whatever whatever performance metrics are being applied to the TLS connection hopefully can be minimized. Now, so that's to me that's an argument for intra handshake attestation in the sense that
Right.
yeah
I will try to clarify a little bit on this specific point. So your point is not about security, your point is about performance, correct?
exactly
Okay,
exactly
so that I can still defend my position, which is that if you defend it like that, intra plus post handshake, I would say that's giving you even worse performance than post handshake alone, which means that for intra you have to generate an evidence here.
yeah
For post handshake, and the major basically performance lag comes from signature, which is the most costly how to say operation, right? And you have to generate an evidence here. You have to generate an evidence for post handshake here. The
yeah
combination means you are getting the worse.
yeah but the client can choose when to do that during the connection. So maybe there's a down if maybe there's a like take for instance if it's a streaming client, right? So it's receiving its
Mhm.
content from a service somewhere. Maybe while the user is sorting through selection menus, that's where it generates the attestation evidence that for the post handshake attestation. Then then it so basically the user sees that he's been able to get access to the selection menus as quickly as possible. But then when the attestation evidence is still conveyed while he's going and sorting through his menus and selecting which movie he wants to watch, by the time the movie starts to stream, the attestation evidence will have been sent. So the client can actually make decisions on when to collect the attestation evidence, when to sign and when to send, in such a way that it still appears to the user that he's able to interact with the service.
Right. I I would say from that perspective, basically what we analyzed is that so we do have numbers in the paper that I will point you to. But what I recall, the difference was not too much. And another point in the performance, which as I understand, is your main point, right? So from performance perspective, so the focus of this work is mainly on security and attacks, and let's say how to come up with the defense mechanisms and so on, and not specifically about performance. Having said that, we have also analyzed performance, and one argument that we have is the post-handshake solution would be worse than intra only for the very first attestation request. Afterwards, it's going to actually perform better because I don't think I have a figure here because Unit already presented that. So the idea there is that post-handshake RFC 9261 says you send over and let's say server is the tester, you send over authentication request, you get back an authenticator. That's one round trip, right? So but for a new connection, which Intra would need, you need 1.5 round trips, which means that you have additional round trip than the post handshake. So it seems that post handshake is adding a bit of a performance lag, but that's not really correct because it's only for the very first connection that you will establish. And for a long-term connection like the streaming application that you were mentioning, it's very much the case that let's say a user now repeatedly wants to check after every hour or so, rather than disconnecting and establishing a connection again, which I would presume will not be good from the usability perspective. There is also performance impact, which is that instead of 1.5 round trips, I could just do with one round trip. That is He can keep watching the movie or whatever. Sorry, go
Yeah, but
ahead.
I'm not arguing against layer related attestation. I'm saying that
Mhm.
you're arguing for only doing application layer attestation, and I'm saying there are scenarios where you can actually address both cases: the initial session establishment and the session resumption. So
So, so
I'm not saying do away with application related
sh-
attestation. I
sure.
agree with you. So
Shush. So, just to clarify, so it does not necessarily have to be on the application layer. Actually, RFC 9261 proposes that it can be, or it proposes that it should be done within the TLS library.
mhm.
Thomas, if he's on the call, may have more details to add on top of that. He was in contact with Watson to kind of clarify that there. I don't have much information, but RFC
Okay, yeah,
9261.
sure. And we can continue the discussion at the next IETF, I think, because there'll be a seal meeting there,
Yeah,
right? Okay.
sure.
Yeah, but I just want to make sure a seal gets chartered that that the performance related aspects are not forgotten. So and that's really kind of my
Yeah.
meta point. All right. Yeah.
Yeah,
Please continue.
sure, sure. Yeah, performance is absolutely in our consideration and is taken care of in post handshake for long-term connections. I mean, okay, so proposed solution very simply as before, just to combine both, which means evidence as well as public infrastructure identity. We need to know who is actually running that service, who is the service provider, who is the infrastructure provider, and so on, whatever that specific use case is. Without that, it would be leading to an identity crisis going over anywhere in the world, and you don't know which specific one that is. With that, I would like to thank all of the people who have contributed to it. And yeah, I'm now open to longer discussions or some other clarification points or anything that, or any comments or feedback that you may have.
Anybody have any follow-ups for Usama? All right. Thank you for the update on this effort. There's a lot of intertwining considerations that have been put into this. So thank you for that. So we are coming up on 10 minutes to the end of the time. I'd say we go ahead and end it. We have a topic for 2 meetings from now, but not for the next meeting. As chairs, I think we need to consider what would be a good fit there. But I think we can call it here. So thank you, everybody.
Thank you all. Thank you, Giri. Bye.
Bye-bye.
Thanks. Actually, just one question. I have something to potentially propose as well. I think it wouldn't be for next meeting though, so should I just add that, or should I discuss this next meeting? This is on attestation of distributed applications.
Sure, go ahead.
Okay, thanks. I'll add that in.
So what did you say? Will you present next time or are you saying now? I didn't follow that.
No, it won't be. It won't be next week. I was just kind of checking whether I needed to. What was the process to get it on the agenda?
Okay. So then you need to talk to the chairs. I think then the
Yeah, so I'll bring it up next meeting then, I guess.
Sure. Thanks. Bye.
Thanks. Bye.